I forgot on day one and had to do it during second period. Welcome, everyone. We'll get started in about 2 minutes. Don't forget to go do your Google attendance form. We are in day 4. So make sure you've answered all 4 questions. There's Bella. Welcome. So Maddie, do you have an animal near you? You do? Okay. Oh, there he is, or she is. Is that that must be the mom, right? That's the mom, the smooth-haired one?
Yeah.
Yes, I think that's Luna. Very cute. Are they being quite noisy? If I remember right, those two can be very noisy whenever they think you're eating something like a wrapper. Like every time a kid would have a snack in the classroom, oh my goodness, it's like a racket. They think they're supposed to be fed. People are like, they're starving. I'm like, no, they are not starving. They are fed all the time. All right, I might have to fix my curtain just a second. All right, Finn Boy. Welcome. Welcome, Finn Boy. And Samantha is coming in. And Matt came in. I don't see a whole lot of you telling me if you've been outside lately. I want you outside getting fresh air once in a while. Get away from the screen. I am making myself get into that kind of routine, or I will spend way too much time looking at the screen. Fresh air is cold. Yes, it is. Oh, I went out, was it yesterday where the wind was so gusting? Oh my goodness, it would blow so hard that the leaves would hit your face. And it hurt. It was really strong yesterday. Soccer practice? Well, then that's getting you out, right? Unless it's indoor soccer. Good. All right, let's get started. About 25 of you, so I'm still missing several of you, but we're going to change things a little bit just because I would rather you have some time on your composting projects when you can work as a team rather than Pear Deck time, because that you can do anytime on demand or during Zoom. But if you look at today's agenda, which should be being shared on your screen, it says that we're going to do See, Think, and Wonder, and we are going to do that. About some ways to visualize some of these basic concepts about ocean and air currents. And then there's the Kahoot and Quiz Is that we'll do as well, but we're going to do that at the very end. And then there's composting. So right here it says composting doc. So I think we're going to kind of switch those two. Because I know it's difficult for you guys to all be in one place with your team other than these Zoom times. I did remember the other two topics I wanted to talk to you guys about. So first of all, there were some misconceptions that happen every year with this idea of positive feedback loops and negative feedback loops. So we always think that positive means good and negative means bad, but in this case, it's the opposite. So in general, a negative feedback loop means that you are going back to a set point. You're returning to your stable point, especially even in the human body. We use these terms all the time. When you're at that 98.6 temperature, you're going to go, if you go above that or below that throughout a day, right, you're going to shiver and try to warm back up, or you're going to sweat and try to cool back down. And that's a negative feedback loop. Your body's trying to bring you back to that set point. The same thing happens in nature. There's fluctuations around a stable point in the environment. Positive feedback is when you have a fever and it gets worse and worse and worse, or There's good cases too, but they're things like childbirth, right? That contraction gets harder and worse. So positive means to accelerate the change, to make it worse. And so in nature, when we study it in environmental science, it tends to be something like taking out the trees, losing your root system. And the more you do that, the worse the erosion gets. Okay, so in general, positive does not mean good. When we talk about positive feedback loops, at least in environmental science, it tends to be an accelerating change. Another one that's commonly used on tests is when the glaciers melt, right? That albedo, that reflection of the light, the more black rock is exposed, the more heat it starts to absorb, the faster that melting happens. So anyways, just wanted to clarify that because I saw some of you answering about feedback loops with some incorrect ideas. And then the other one was what a limiting factor is, because that's another huge concept. Because the limiting factors are things that tend to restrict growth that you run out of first. So if you are a plant or an algae or something, nitrogen and phosphorus are limiting factors. And that just means that I have to have those elements to build my tissues in my body. So if I run out of them, then I can't grow. So I won't grow. It limits the growth of something, of a population. So limiting factors are things that are in short supply or are absolutely necessary for you to grow and build, a new organism, a new tissue. And so when we give a system extra nitrogen and phosphorus, it causes things like blooms. So that's when we give those extra things, then they go crazy because now I just took the limiting factor that was controlling that population and gave them a whole bunch of it, right? And now they can grow and build more proteins and divide. So just make sure you understand that concept. Both limiting factors and feedback loops are really important themes in environmental science. All right, let's go ahead and get started with See Thinking and Wondering. So if you go to your classwork tab and you go to this week and you scroll down, you will see a thing that says See, Think, and Wonder on Ocean Currents. And we are going to go watch 2 clips today and make observations. They're both really short. And kind of the 2 biggest targets here are for you to start thinking about molecules and what's going on with them when there's a temperature difference and when there's a salinity or a salt concentration difference. So, and then it's completely up to you if you want to get extra lab or project points for you to do the flip grid, or you try these as well. So you go and try these on your own. Let me make sure I'm sharing the right screen. Share this one. And this was not meant as homework. This was meant for today in class. So if you already did one of these, that's okay. If you did one of these, then just change your text color, because I actually linked 3 of them here. This one that says simulating is actually on temperature. And then this one on currents is on salinity. So we're gonna, and this one's just another one, I believe, on temperature. That's very similar to this first one. No, you don't have to have your stuff right now. We're just gonna just watch it. If you want to actually do it on your own for extra points, then you can go to this flip grid and film yourself doing it. The first one I just thought was kind of cool. And actually it's taken from, I think, a 5th grade thing I found. It's not anything high level, but I think it's a great visual and it allows you to wonder at a higher level. So it's going to allow you to explore other things using the same kind of setup, which is why I liked it, because most of them, it was hard to visualize what they were trying to show you. And this one actually looks like it would work. I haven't played with it. I tend to not be able to make it look quite as pretty as some of these people do. Any other questions before we get started? So I see Patrick and Grace and Matt and Devin, Maddie, Kendall, Drake, Sophie, Cookie. Well, I probably see other people too. Prabjeev, Leah, Bella, Sammy, Hope, Aslan, Conrad, Ben Boy, Luke, Anna. All right. If you are ready, please put a thumbs up by your name and or a yes by your name, either one, just so I know we are ready to look at some of these and talk about them. I see, good. I see a bunch of you. And if you need me to go slower, then put that little go slower gray thing that goes to the left. Right, I'm waiting on a couple of you to say, yes, you were ready to go. Oh, thank you, Sophia and boy, you guys are thinking ahead. Yes, I will eventually need you guys to put your numbers in front of your names. That will make things go a lot quicker when we are done with the See, Think, and Wonder to get into our composting groups. All right, so I'm going to do the simulating, the one about temperature first, the one that I think looks pretty cool in terms of simple supplies and being able to visualize some of the main ideas here of temperature differences. This can be important when we think about things going on in the air and the water. Okay, is what do molecules do when they get cold? What do they do when they get warm? So I'm going to go ahead and start this first one. And you're just, again, like we did.
Welcome.
Like we've done before, in the observation C section. Let me make sure it's sharing the right screen. Oh, it's on the exact same thing. That's interesting.
Welcome to Science Explorations. Today's lab is all about ocean currents. We're going to use colored water to see how water currents move in the ocean. How do we make a current? We poke a hole in a paper cup. We fill the cup with colored water and set it in a tub filled with regular clear water. Then we let the water flow out. We use colored water so that we can see and identify the water in the current as it flows into the rest of our ocean. Before we begin, I want to talk about the concept of pressure, since it's pressure that will send the colored water out through the little hole in the cup. Pressure is simply a force pushing on an area, like the force of these books pushing down on your lap. The more books we add, the higher the pressure on your lap. You can think of water in a cup or in the ocean in the same way, as layers of water resting on each other. The pressure at any level of the cup depends on how much water is sitting on top of it. So the pressure on the bottom of the cup is higher than the pressure at the top of the cup. For this lab, also notice that in order for a cup full of water to rest on the bottom of the tub without floating off, the water level in the cup needs to be higher than the water level in the tub. Let's get back to our ocean currents. I'd like to see what happens when I let a warm current and a cold current encounter each other in the ocean. Then, as a control, I'll watch what happens when I let two currents of the same temperature encounter each other. Let's set up our first activity. I want to poke a hole in the water cups to allow the warm and cold water currents to flow into my ocean. I'm going to measure about 3/4 of an inch, or you know what, let's call it 2 centimeters from the bottom of my cup. And I'm going to poke a push pin through. I like to hold the pin, and then I have my finger nearby in the back, but not near enough that it's going to get poked. And there it is. We'll do the same thing with the other one. And there we have it. So here's my warm water and my cold water. I'll put some red food coloring into my warm water and some blue coloring into my cold water. Now I can use the colors to remind me that the red water is warm and the blue water is cold. Now we place our warm and cold water into our tub, which represents the ocean. We carefully fill the tub with room temperature water. We want the level of the ocean water to be higher than the pushpins, but not as high as the water level in the cups, or else the cups may start to float. Now I'll remove the pushpins from the cups, and the pressure of the water above the level of the hole in each cup causes the cold blue water and the warm red water to flow into the tub. Because the red water is warm, it is less dense than the ocean water, and the warm red water rises to form a layer on top of the clear water. In contrast, the blue water is cold, so it is more dense than the ocean water, and the cold blue water sinks to the bottom. As the currents of different temperatures flow, they transfer heat through the ocean in a process known as convection. Now let's set up a control with the red and blue currents at the same temperature as each other and at the same temperature as the water in the tub. This time, the red water, blue water, and ocean water are all at the same temperature, so they also have the same density. And with all the water at the same temperature, we see that the currents don't separate out into layers. Instead, the mixing of the currents is driven by the simple force of the water coming out of the holes in the two cups. In this video, we've seen how to model ocean currents using colored water and a clear tub. You can try this activity yourself. And here's some food for thought. This is also a good model of how air currents and warm and cold fronts move through the atmosphere.
All right. And like I said, yeah, this came from fifth grade, but I really like the ability to modify it and visualize it. Oops, I better stop this or it's going to keep going. And I'm going to pull up your So You Think of Wonder. So you should have your C part done. And now I'll be moving on to your thinking and wondering for this. I'm just checking now my own page on this. Good. I see Grace adding some stuff, math, Kindle. Good. I like Braden using vocab, thermocline developing. If you are a scuba diver, you definitely know about thermoclines. Leah, see Riley, Rob G, writing. Colin, good. Danny starting. Excellent. Now we should be starting to move into the wonder part. Like, what else would you try or modify? What kind of things are you questioning that you could set up and do differently? like Patrick's wonderings over here, the kind of the order of putting in the water, fast or slow. If a cold front or warm front comes in quickly, does that matter, right? What would happen? Oh, was it sealed? Okay. Good wondering. I hear about, is this going to represent our oceans? So what are some limitations, right, to the model? So one of the big, huge themes for you guys in all grades for science is to understand models and understand why we use them and then understand limitations of them. So I really like, who was that? That Maddie said that? It's Kindle. There we go. Maddie, okay, that's fine. Yes, what happens when the ocean is warmer? Yeah, wonder about the, also, what about, I'm looking for anybody wondering about 20 years from now. Good, I see some questions about salty or fresh, which is what our next clip's gonna be about, Luke. Great transition for us. So another minute, put some sort of wondering down there, and then we're gonna look at what Luke wrote right there, which is what happens though when we add some salt to this system. We talk about the ocean, right? We've got some salt in there as well. So salinity is another factor we've got to consider. Good. I like that you guys are applying Mexico and Hawaiian waters and kind of temperature differences. Good. Yeah, what happens? So Riley's wondering about if you increase the temperature and make and slow look at these differences in temperature between the cold and the warm, what other differences do you see in that movement of those colors and those currents? Dirt, sediments, that's interesting. I like that. I never even thought of that. So yeah, that's why I love looking at what you guys wonder. Sophia said, I was wondering things that I hadn't even thought of, but that sounds really interesting, right? Because if you have sediments and dirt in there, that definitely is going to impact the heat kind of capacity that the water is going to hold. And what does that do to some of your currents too? Or particulates in the air, right? Right. 30 seconds, and then we're going to go ahead and kind of look at an application, very similar setup with salinity. And I think this is just like a 1-minute clip. So let's go ahead. It's like most of you have wondered.
What I have to show you here is a couple demonstrations that I do at the beginning of our study of ocean currents.
Sorry, I lied, it's 2 minutes.
Before my ninth graders here at Helena High School can understand ocean currents, I think they need to realize that salinity affects the density of water. To find out the amount of salt to use and to learn a fun way to present this to your students, I have provided a notes handout that you can access by selecting Show Support File on this web page when you are finished watching the video. In the second part of the demonstration, I add several drops of food coloring to the fresh water and then stir it up. And then what I do is I use a spoon to cushion the fresh water as I pour it into the beaker containing the very salty water. And as you might expect, since it is less dense, the fresh water floats on top of the salt water. The next thing I do is I ask my students to predict what will happen if I place a golf ball into the beaker containing the two layers, the layer of salty water on the bottom and the layer of fresh water on the top. And usually.
All right, and we're not going to say what the ending of that is, but I want you to go ahead and, with a different color of text, do some wondering and predicting for this one. So what's going to happen now? And just highlight your text so I know where your wondering changes for this salinity one. So what's going to happen when he puts that golf ball back in there? Go back to this. And obviously, if you wanted to do this, you don't need beakers. You could just do this in any clear container that you can see and film. So all you need for this one is salt, food dye, water, and a containers. And I'm pretty sure in your first, oh, you guys have only got one kid. I was going to say my other class has two, that you have food dye. It might not be blue versus red, but all right, we are running short on time, but I just wanted to make sure that you guys knew about these two demos, and that at the top here is the hyperlink to the Flipgrid. So if you want to try them on your own and get some points for labs and project scores. Why is it not allowed? Anyways, I think I'm accidentally in my other Google Drive. You're going to go to the one that says simulating ocean currents when it clicks on there. But I'm in probably the wrong drive right at the moment. Yeah, I clicked on the wrong one. Oh, that's right, because I'm not, your guys is at CSD 117. So it's programmed to only allow you to put videos on there, not apparently teachers, which have different emails. So yours should actually work. All right. Hopefully everybody has had a chance. I'm going to go look to put your number in front of your name for composting. And your team will have a chance to discuss and make sure that you have added a question to your Google Doc and a prediction and some methods. So it says, or materials. So we're kind of flipping these two, the Pear Deck and the composting time. So add a question, a prediction, and a materials to your Google Doc. And I will get everybody on with their group to be able to discuss that. So you can start building by Sunday. There's a few of you that do not have numbers yet. So go check where your Google slide is and what number your slide is and put that on your name. I'm going to start making those rooms. If you have any questions, put those in the chat box or unmute. Okay, so I see. Just lost somebody. Hopefully they will come back in. Not letting me. Oh, there we go. All right, so Haley, Bella, Samantha, you will be in room 1. Maddie, Grace, Kendall, Patrick, room 2. Oh, she did just get, or he just got kicked out. There we go. Room 3 will be the 3s, Addison, Hope, Cookie. Oh, you guys are moving around on me. Room 4 will be the 4s, Aiden, Connor, Prabjeev. Room 5, Anna, Aslan, Malia. Room 6.
I'm
Yeah, go ahead.
also in room 5. I just changed the number for some reason. It was an accident.
Okay, I can move you guys that here in a second. Okay, now these are off. Oh, well. Braden and Daniel, is anybody else in your group? I thought you guys had more than 2. I guess I will fix that in a minute if there is anybody else. All right, so Cole, so I'm gonna open the rooms and then I'll kind of get the last 5 of you that either don't have numbers or need to be moved. So Matt, Anna, all right, Colin, you're with Braden and Daniel. Okay. Braden and Daniel got put in roommate. Okay. And Madison, are you still there or are you off? Because I know you said you were not feeling well. Let's see which group she's in. Madison, where are you? Yes, if your team doesn't need you, and you're I would at least go with your team and kind of get on that Google Doc so there's a record that you were kind of here when I go to look at it later. Who is in your group so I can tell them? So I don't see your name on any of these teams, but I know that you were on one of them. And if, oh wait, there you are. You were with Joseph. It looks like Sophia. Term 6. Okay. Sort of. They're all in.
Hey, Miss Roberts.
Yeah, what's up?
So we had a question about the make your own prediction. We all kind of put in our ideas and decided on one group prediction. Would that be okay?
I still. Oh, so you're going to do it in like orange text? Like
Yeah,
at the top, it says if you guys all discuss it as a
we
group.
made it in orange.
Yeah.
Okay, that's fine. Yeah, as long as you're still that you all show up today on the edit history somewhere, and then you put that in orange, then I know that that's kind of what your group did.
And then for the constants, you said we weren't allowed to use the word same. So exactly, like, what were we supposed to put there?
So go ahead and tell me what are some things, or what's your investigative question?
Like the amount of green and brown materials in the compost container.
Okay, so you're going to look at that ratio. So what are some other things that you know that you're going to, between all of you, going to have to keep the same so that it doesn't affect the compost?
Oh, so you want us to list the things that are the same without actually just using the word same?
Well, I want you to, so give me an example. Just give me.
Well, we're all going to put our container in the garage.
Okay, so that means you're all going to be controlling what by doing that?
Like the amount of sunlight it gets.
Okay, so you're all going to put it in the dark, or are you going to, what if somebody has, is that what you mean?
Yeah, there's not going to be that. Well, it'll be a little different depending on what your garage looks like, but it'll be about the same.
Okay. What else? What else will you need to control for?
the same container, that we're all using the same container and the same amount of soil.
Okay, good. So instead of saying same amount of soil, what could you say that would help someone else recreate?
A specific measurement of soil, which we haven't found out yet, but we're going to.
Yeah, that's exactly what I'm
I
looking
thought we were
for.
going to use 1 quart of soil.
1 quart? Okay.
And try to use metric rather than American. So how could you do this in a metric way?
I'm not sure how to convert that to the metric system.
So go ahead, so that's a good job for one of your team members to kind of look up that conversion. But what are some other things you could do as far as amounts of things like soil or brown material or whatever you're going to be putting in there that you guys could use specific amounts that are metric? So what's something you could measure? That's each of you. What do you guys think? Kendall, Maddie, what do you guys think?
Could you repeat the question, please?
Yeah, how, what is something specific? If I needed someone to read my procedure and be able to recreate it, right? That's what scientists have to do. What could I write about the amounts of things that I'm going to put in there to start with? So my amount of brown material or maybe my amount of dirt.
Like the specific material and the measurements and like cups?
Yeah, but what kind of measurements would I be using besides the American, like set of cups or quarts, or what else could I do?
I don't know.
So I'll let you guys discuss that and kind of Google it and see if you can come up with what would be the metric equivalent of things like cups and quarts and things like that. Okay. Or if there's a better way to do things like mass.
Thank you.
Uh-huh. Let me know when you guys figure it out. Hey, welcome back. I know I brought you back a little early just because there's one other thing I want to talk about before we play our game. So as you guys come back, hopefully you can see my screen on your composting project. I'm going to double check that. Nope, it was on the whiteboards. Why does it keep moving, you guys? There you are. Sorry, I'm just trying to get my Zoom so I can see you, even though I'm seeing black boxes today. All right, let's see. So I just want to go through this process. I think I did it second period, and I don't think I did it with your first or third. Just so you can see what I do on Sunday when I'm looking at your guys' work, and I'm going to pick on a team randomly. I'll pick on Estella's group here. I go to this, I go to your link, I click on your document, and this is just the start of it because I want to play our game and see how we're doing on the concepts for chapter 4. But once I get here, I go and look at who made the edits and changes, and I count per team member your edits and your participation and kind of what you did. So I look at your full history and I look over here. So today I should see everybody. So right now I'm missing Anika from December 3rd. So that's kind of how I look through these. Anytime I give you a live session for your team I want to see all of you appear on there because that's the very first thing I'm going to do every time I look at these projects. All right, so let's go ahead and see how we're doing just in general on your content knowledge. So this is specifically from Friedland chapter 4. We're only going to play it until the end of class. So we have about 4 minutes. So go ahead and join the my quiz 420337. And we'll just play for a certain time limit. This is the same one that's available for you to do for extra credit points on your test for this chapter. Also, if some of you could start getting used to having your videos on, I am going to be sending out a form that has to do with you guys knowing that I am using, I have to use these recordings for my, what's called my MOC, maintenance of certificate. It's not for my teaching certificate, it's for my national board certificate. And I am not sure if they're going to accept black boxes. So it would be very nice to start seeing your guys' faces. And if I have to go to administration for more consequences, I gotta be able to see you guys. I don't know how they're gonna accept black boxes, but maybe I need to find out. All right, let's get started. Daniel, thank you. I can see the top of your head good. And Maddie, thank you very much. Let's get used to this. I see 26 of you. So if you are late getting started, just go ahead and do this. You can still add yourself. This is a long one. I played this one yesterday for about 15 minutes. But I liked it because it really covered everything, including the biomes. The only thing that this doesn't do, that the Kahoot that I gave you will do, is have pictures. I like pictures. Okay, 30 seconds. Let's see who our winners are. Well, our accuracy is slowly going up. Right. Let's look at the winners. Joseph, Braden, and Anna. Nice. All right, so again, practice those as much as possible. That will kind of help you with the main concepts. And I am out of time. So if you have any questions, or I've asked you to work with me today during conference time, come on back at 10:45. Or if you're going to stay after and ask questions now, we'll be here for a few minutes.
Thank you.
Bye, bye you guys.
Thank you.
Bye guys.
Is there going to be a test next week? Because it says on Launchpad, like we have our unit test on Wednesday.
Next Wednesday? Let me look.
Yeah.
I don't show that. I mean, I don't show it for my week at a glance. It might be on Launchpad, but we are not that far yet. It just says
Okay.
we're doing some FRQs, but we're not going to do that actual test yet.
Thank you.
Mm-hmm. Right, Madison, are you feeling any better? Oh, thank you, Periel.